I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will discuss the topic on types of arrays for the course Antennas and Wave Propagation. So, today's learning objectives and overview, we first see the array types. We are going to see the four fundamental array configurations and also their operating principles. Next, we see the radiation pattern, that is the directional characteristics beam forming in different array structures. Finally, we see practical applications and design of antenna in real world. And in the empathy part of design thinking, we must understanding antenna arrays and what is the need of antenna arrays. So the antenna array is configuration of multiple antenna elements, and it is arranged in space to achieve higher directivity, specific radiation characteristics. So why the multiple elements are needed in antenna arrays? We can enhance the directivity and gain of the antenna, and beam steering applications, it is very much important, and improved signal to noise ratio we can obtain, and flexible pattern control also we can achieve. So these are the need for multiple elements and the definition for antenna arrays. So in the defined part, we are going to see the first type, broadside array. So in the broadside array, all the elements that is all the antenna elements in an array are fed with equal amplitude and equal phase. That is no phase difference between the adjacent antennas. And in this case, the maximum radiation occurs in the directions perpendicular to the array axis. So if we see the key characteristics, the phase difference is 0 degree or 360-degree. Spacing is typically lambda by 2, which is the resonant length. Lambda is the wavelength at the frequency of operation. And here we get bidirectional pattern. And the broadside array applications, these are useful in various applications like communication base stations, and in the broadcasting antennas like transmitting signals to radio and the television, and the television reception systems also. These broadside arrays are very much important. Next, in the defined part, we are going to see the end-fire array, the next type of antenna array. So the operating principle is maximum radiation occurs along the array axis, and the elements are fed with progressive phase shift but the same amplitude, and the directional beam along the line of elements. So if we see the phase relationship, the ordinary end-fire array, the phase difference psi is equal to minus beta into d. So d is the distance between the adjacent antennas in the array, beta is the phase constant, and this is for Hansen-Woodyard array. It is minus of beta d plus pi by n, and here in the end-fire array we get highly directional and also unidirectional radiation pattern. So the applications, we can also use it Yagi antenna, direction finding systems, and point-to-point communication links. So in the ideate part, we are going to see the collinear array. So this collinear array, the third configuration, is similar to the first type broadside array. Only difference is the antenna elements are stacked one over the other. That is, the multiple dipole elements aligned end to end along a common axis. Typically, it will be the vertical orientation. This is for omnidirectional coverage. So, phase synchronization, all the antenna elements in the array are fed with equal phase in order to get additive radiation in the horizontal plane while cancelling the vertical radiation. And the pattern formation practical implementation are, it creates omnidirectional coverage in azimuth with the increased gain, and also we get a narrower vertical beam with concentrates energy horizontally. So now the fourth type or fourth configuration of antenna array is parasitic array. So parasitic array, this can be considered in the ideate part because this eliminates the feed line problem in broadside end fire and the collinear array, the last three types of array. So here it consists of unique design approach, that is only one element which is called as driven element is directly connected to the transmission line or feed point, and the additional elements which are called as parasitic elements are electromagnetically coupled with this driven element, and because of mutual impedance they also get excited. So there are three type of elements. One is the driven element, which is the active element, and other two elements are reflector and director. Reflector size is 5% higher than driven element, and the director size is almost 5% less than the driven element, that is the center active element. So the advantages of parasitic array, they are useful for cost effective design. We get excellent directivity with and also minimal complexity, and the main advantage is the simplified feeding network we can obtain from the parasitic arrays. Now, next is the prototype. So far we have seen the various antenna configurations. The four types we have seen. One is broadside array, the second is end-fire array, third case is collinear array, and finally we have designed the parasitic array. And we have seen the radiation pattern and the applications, etc. So now comparative analysis, we are going to compare the four type of array. The radiation direction for first case broadside array, perpendicular to array axis, end-fire array along array axis, collinear array is omnidirectional, parasitic array toward directors. Phase relationship broadside array in phase, end-fire array progressive phase shift between the elements, collinear array is in phase but vertical configuration, parasitic array electromagnetic coupling. Applications, that is primary applications, broadside array it is for broadcasting, end-fire array point to point links, collinear array is mobile base stations, and parasitic array is for television signal reception. So for broadside array improvement, 3 to 6 dB gain and 10 to 15 dB gain can be achievable with Yagi-Uda parasitic arrays. Summary, so far we have seen the array fundamentals, configurations, and also how to choose the antennas for different type of applications. So we can also simulate by using various simulation tools. The advanced topic is phased arrays, adaptive beamforming, and MIMO systems. Assessment for long distance communication. Which of the properties mainly necessary for the antenna? It is high directivity, and the following is false about the single antenna. For long distance communication is we can no side lobes. Thank you.